Today's topic is going to be exponential and theoretical probability. Those are some pretty big words, but I think once we get into the examples and discussions, it'll really be easy for you to understand. So let's go to the first slide where we're going to cover some definitions for each one of those probability names. So theoretical probability. So theoretical is a big word that just suggests that things are based on a theory, an idea, rather than an experience. It's all about expected results based on what you know. And the word theory just means well thought out explanation, idea, thought, opinion. Hopefully those definitions help you understand more about the theoretical probability. But for more information, I'm going to share some more details with you about what it is. Theoretical probability is the ratio of the number of favorable outcomes to the number of total possible outcomes. And if you remember ratios, it's just a fraction, one number over another. So you will see the equation in just a minute, or the formula in just a minute, that you can use to calculate and find the theoretical probability. And it is also a ratio that describes what should happen, right? People are thinking about what should happen based on the information you're given. So with those things in mind, the definitions and the other tips that I have here for you, let's look a little further into theoretical probability after we take a look at experimental probability. So experimental probability, the definition. Experimental, the probability that something will occur based on the results of a repeated experiment or of repeated experiments. And an experiment is when you try or you test something in order to discover or prove something. And that came from dictionary.com. So with experimental probability, you have to conduct an experiment several times and record the results. And I'll show you an example of that. Every time you conduct the experiment, it's called a trial. You may have heard that term on the news when they say studies and trials and things like that. Well, in this case, we're talking about mathematical trials. But we will show you what that means in a minute. And again, it is a ratio that describes what happened by using the information from each trial or experiment that you do. So let's go forward and look at some examples. Well, first let me show you the equations. Here's the equation for experimental probability. It is the probability of the event occurring. That's why you have P, open parentheses, event, close parentheses, equals the number of times the event occurs divided by the total number of trials. For theoretical probability, we have the probability of the event, with event being in parentheses, and you'll see why, because the event changes with each one of these. It could be anything that's the event, but I don't want to confuse you. So let's move forward. The equation for finding the theoretical probability, it is the number of favorable outcomes divided by the total number of possible outcomes. Now, I know I've said a lot of things and given you a lot of information, but I think when you see some examples, it'll make sense. So let's look at an example for experimental probability. Flip a coin 10 times and calculate the experimental probability. Using the equation, the probability of an event equals the number of times the event occurs, the total number divided by the total number of trials. We can use the data we have over here from when we tossed our coin or flipped our coin 10 times, and we got either a tail or a head, because those are the only options you have for a coin. It's either going to be a tail or a head, right? Heads or tails. And when you flip it, you either get a heads or you get a tails. And so when we used When we flipped a coin, I actually flipped a coin. I took a nickel, I flipped it 10 times. That's why you see these numbers here from 1 through 10. Every time I flipped it, I wrote down what the results was. So whenever I got a tail, I wrote tails on my table. And whenever I got a heads, I wrote heads on my table. So you can see that I actually had four heads. 1, 2, 3, 4. So my event is I will get a head when I flip the coin. I will get the head side of the coin when I flip it. That's my event, right? The probability of getting a head, I take the number of times it occurs, which is 4. I divide that by the total number of times I flipped my coin, which is 10, and I get 2/5 as my ratio, which means the probability of getting a head when you flip a coin 10 times is every 2 out of 5 times you will get a head. Now, I didn't put tails on here because I want to give you a chance to think about what the equation would be if we wanted to look at the probability of getting a tail. So if we say our event is now the probability of getting a tail, we would have to go over here and count. We'll have 1, 2, 3, 4, 5, 6 times. When I flipped my coin 10 times, I had a tails to come up 6 times. So the probability of getting a tail would then be 6 over 10. Oh, terrible 6. 6 over 10. And if we reduce that, divide both top and bottom by 3, we get 3/5, which means 3 out of 5 times when you flip a coin 10 times, you're going to get tails. And of course, you could have done it a lot easier just by subtracting the number 4 from 10 to get 6, put the 6 over 10, and then get 3 over 5. For all of you that find it easy to do that, you do that. But for those who find it difficult, I want to show you how to do it. All right, let's keep going. I have an example for you of theoretical probability. The theoretical probability is a little easier. As I said, when you have a coin, you either have a head. When you flip it, you get a head, or you get a tails. The tail is just the back of the coin. Maybe I should have made sure that was clear. It's the back of the coin. There are only 2 options, either a head side or the tail side. If you watch football or any other sporting game that involves flipping a coin, they have special coins, but each side is different. In this case, this is a standard nickel, and it has a side with the face or head of a person on it. All of our coins do in America. And then they have the bottom, the back of it, which has different pictures of buildings and things like that, depending on the coin. But the point is, you only have 2 options. And so when you're looking at theoretical probability, the denominator will always be the total number, just like it says here, is total number of possible outcomes. And what are our possible outcomes? A head or a tail, which gives us a total of 2 possible outcomes. If you flip a coin 1 time, you're either going to get a head or a tail, which is why you have the 1 in the numerator. You can only get one of the 2 every time you flip that coin if you're dealing in theoretical probability. That's the difference in what we just went over with experimental probability, where you can flip it a number of times, write your results, and get your ratio that way. This is a lot simpler, just a total number that you can possibly get and the one option that you can get for each of the sides of that coin. All right, let me erase this and then we will move forward. I was just showing you the heads and the back and the front of it. So here's another example of a theoretical probability problem. Again, we have our equation. The probability of an event happening is the number of favorable outcomes divided by the total number of possible outcomes. The total number of possible outcomes for this particular example is 8 because we have 8 numbers on the wheel, right? So what's the probability of spinning a 1? It's going to be 1 out of the 8. The probability of spinning less than a 5, you have to do a little work. How many numbers are less than 5? You have 4, 3, 2, 1. So the probability of spinning a 5 is 4 out of 8. So your ratio would be 4/8. All right. Next, let's keep going. We have we have 4, 3, 2, 1. Make sure I show you the 4 options that we had. All right. So now, what's the probability of spinning an even number? Well, let's look at the even numbers we have. We have a 2, we have a 4, we have a 6, and we have an 8. How many are there of those? There are 4. So the probability of spinning an even number is 4/8. That's our ratio. All right. What's the probability of spinning a number divisible by 6? This could be tricky depending on the number on the wheel. In our case, it's very easy. The only numbers that can be divided by 6 are these, the numbers 6, 7, and 8. Because notice, I didn't say divide it an even number of times. 6 can go into 6 one time, 6 can go into 7, 1.1 something, and 6 can be divided into 8, and you can also get a decimal answer for that. So be careful if you have these questions on the test so that you don't get tricked. The probability of spinning a number divisible by 6, we actually have 3 of them, 6, 7, and 8. So our ratio in that case is 3/8. Okay, hopefully everybody's still with me. And following. All right, let's do another experimental probability. The equation, the number of times the event occurs, and the total number of trials. So this is what I did. I actually spun this wheel, and the first spin, I actually got a 2. It stopped on 2. When I went to spin it the next time, it stopped on 4. So I recorded my 4. I spun it again, and it stopped on 5. So I recorded the number 5. One more spin, a couple of more spins. I did it again, and it stopped on the number 8. And then when I spun it one last time, I got it a 3. The number of times I decided to spin this arrow, this dial, was totally up to me. I could have gone on and done 5 more, 10 more, 15 more. So I don't want you to think that 5 is the max number you can have when you're working a problem like this. It can be a very large number. It could have been just 2 spins. It could have been a number of things. So you have to be careful and remember that the number of spins, if the teacher does not tell you what that number is, she tells you it's up to you, then you need to decide how many times you're going to spin a wheel or flip a coin or do the experiment, because that's what each one of these things are called. Every time I spun this wheel, that I was conducting an experiment. And so with the results that we have, I want to ask you a couple of questions. What is the number of times the event occurs? Do we have any of these that occurred more than once? No. By chance, all of them occurred one time. And so that makes all of our answers easy. If your teacher says, what's the probability of spinning a 2? And you have a chart that looks like mine, guess what? The probability is 1 out of the total number of trials, which is 5, so that's 1/5. If she asks what's the probability of spinning a 4, based on our experiment and our trial, we only got 4 one time, so that's 1/5. And so for all of these, we didn't have any numbers that repeated itself. Isn't that something? If you did have a number that repeated itself, your numerator would need to increase. So for example, what if I had done 6 spins and had gotten a number 3? Then that means that this would be 2/5. Right? Okay. Hopefully this will help you. Don't forget to subscribe and give us a big thumbs up if you like this video, and share it with others. Thanks for watching. We'll see you next time. Take care.